And this we call reflection coefficient. This we call transmission. Okay? And it does depends on this Z1, Z2, Z1 and Z2. And we didn't go detail about how to get the Z1, Z2. But it's obvious that we got this by just solving differential equation and boundary condition. And by assuming these three waves. Okay? Right? Okay. Now, what is Z? We found that Z, in fact, is the ratio between the force acting in y direction and the velocity in y direction. If you go detail in derivation, we can find it. And that is tension divided by C. Okay. How we get this result? We have Z1, H1, and Z2, and these three waves has to satisfy boundary condition over here. That means velocity in y direction should be same, and the force in y direction should be same. And the force, this force is TL dy dx and minus, because there is a string and there is a tension. Okay, force in y direction is a TL. The slope in this y direction is a dy dx. And this is towarding to the negative side of positive y-axis. So that is the force at x equals 0 minus. And this force is TL dy dx on x equals 0 plus. That has to be same. And velocity in y direction is dy dt at x equals 0 minus, and this is the velocity in x plus, so that has to be dy dt x 0 plus. That has to be equated. If I take dy dt over here, I will just get g1 prime and h1 prime at x equals 0 has to be same as g2 prime, right? So one equation I got is h1 prime, no, g1 prime plus h1 prime at x equals 0 minus has to be same as g2 prime at x equals 0 plus. That just simply means that simply writing the requirement of velocity continuity at x equals 0. And this one minus TL dy dx on x equals 0 minus has two components. One is g1 prime, and I have 1 over c1 over there, because if I differentiate this with respect to x, I will get 1 over c and the minus. So I have plus over there. And also I have TL over C1 H1 prime at x equals 0 minus, and I have a similar TL over C1 and C2 G2 prime at x equals 0 plus. Okay, and I have to solve these two equations to get the ratio between G1 and H1 and G1 and G2. I can solve it, and as a result of that I can get this relation. Okay, let me summarize what I have been talking to you. Okay, I have governing equation, I have two strings, and there are three waves are possible, and the ratio of these waves has to be determined by the boundary condition over here. And the boundary condition says velocity has to be continuous and the force has to be continuous. Those two boundary conditions give us this result as well as this result. Okay, so we have a mathematical form, apply the boundary condition, we got the result. Then what we have to do? We have to enjoy it, right? Now we are ready to enjoy the result. That's the most interesting part that is given to us. What does it mean? Oh, impedance is how much force required to have a unit velocity. If impedance is big, that means I need a lot of force to get unit velocity. If impedance is infinity, that means I need infinite amount of force to get unit velocity. Or I could say, if impedance is infinity, then there's no, very small or no possibility to move the point.